right, hi guys. You should have just taken notes over your PowerPoint. I'm going to go through a couple of highlights and examples, and then hopefully you'll be caught up. If you're still confused after today, don't worry. We are going to review everything on Thursday, but just make sure that you are actually doing what I'm asking you to through this video, okay? So I'm going to teach you a quick way for writing formulas. It did not say it in the PowerPoint, so I want to make sure that you get this information. Hopefully you saw that, for example, with sodium and then chlorine, this went here to form a sodium ion and a chlorine ion, and that is a sodium chloride ionic bond, okay? So the formula, since we needed one sodium and one chlorine to complete these octets, would be just NaCl, one of each. However, if you're given more complex ionic compounds that take more than one of each atom, there's a way to predict how you write the formula without having to do all this, okay? So I'm going to show you. It's called, and you might get out a separate sheet of paper just to jot down these notes that I'm giving you since I'm not there in class. You'll have these examples on a separate sheet of paper that you can also keep as notes so that you have something to remind you, okay? So pause this video if you need to get out a piece of paper and start writing, okay? So this method is called drop and swap for writing formulas. You're going to take the charge of each ion and drop and swap them. So how we calculate charges, now this is a used periodic table, so I'm sorry, but group 1 all has +1 charge, group 2 +2, group 3 +3, then we skip, and then we go -3, -2, -1, okay? So make sure that you remember, or that you have that labeled on your periodic table, how to predict the charges of each element. All right, so let's say I give you magnesium and phosphorus, okay? In order to predict if these two, what the formula for these two will be if they form an ionic bond, we're going to find the charge of each one of them. Magnesium is in group 2 on the periodic table. That means it has a +2 charge. Phosphorus is in group 5 on the periodic table. That means it has a -3 charge. Okay, this is step 1 to writing the formula for this compound. Once I know the charges, I'm going to erase the actual pluses and minuses. So I just have the numbers. And then I'm going to drop these numbers. So I have Mg2P3. And then I'm going to switch them. Switch places. So my final would be Mg3P2 for this compound between magnesium and phosphorus. And hopefully on the notes that you caught on, in a binary compound, meaning between a single atom on the periodic table and another atom on the periodic table, not involving polyatomic ions, when you name this, the metal keeps its name the same, magnesium, and then the non-metal is the one that gets IDE to the end of its name. So our ending would be phosphide, and that would be the name of this compound. So writing the formula and then naming it. Example. Okay, and that's how we would write a name for any ionic compound. Now, let's say that I have a polyatomic ion here. Okay. Okay, same exact thing. So you're going to look at your polyatomic ions list right here. And these pair with metals or nonmetals. So most of them are negative ions. That means they pair with a metal that's going to be positive. The only one that doesn't is this ammonium right here because it's your only positive polyatomic ion. So any of your negative ones are going to pair with a positive ion and drop and swap the exact same way. So let's say I have sodium and sulfate. Okay? Sodium on the periodic table is in group 1, giving it a +1 charge. Okay? Sulfate, it is a collection of atoms that makes an ion, which makes it a polyatomic ion. These ions are all on your sheet, and you will get to use that sheet on a test. You don't have to memorize them, but you do have to be able to recognize that this is a polyatomic ion and that it's not on the periodic table. This sulfate, if you look at your polyatomic ion sheet, has a -2 charge. And I think on your periodic or polyatomic ion it says 2 negative. It's just the same thing as a -2 charge. So when we're dropping and swapping these, we erase the positives and negatives, we drop them, and then we swap them. So this 1 comes over here and the 2 comes over here. So my final formula would be Na2SO4. And anytime we have a 1 down below, we never write it. So that's why that 4 does not have a 1 after it, okay? And the last thing that I want to mention, well, I guess this would be your formula, and then your name for this would be sodium sulfate. And this is an example of an ionic compound involving a polyatomic ion, so not a binary compound. All right, and then the last thing, well, one of the last things I want to mention about polyatomic ions is, let's say I have, magnesium and nitrate. Magnesium is in group 2. It has a +2 charge. Nitrate has a -1 charge. So if I were to drop and swap these, anytime I need more than one polyatomic ion, I have to put it in parentheses. So what it's going to look like, this 2, I erase these, and then the 2 comes over here and the 1 comes over here. So my final formula would be Ng parentheses NO3 2. Okay? I would never write NO3 2 because that looks like I have 32 oxygens, and that's not correct. Okay? So I need these parentheses. And then the final name would be magnesium nitrate. All right? So that's involving polyatomic ions, writing formulas, and then naming them. Dropping and swapping. All right. Then the very last thing that I want to go over is transition metals. Transition metals are weird because they do not have a predictable charge. So anytime you have a transition metal, you're going to have to be given the charge so that you can put it into your formula. So what you're going to see is something that looks like this. Iron 2 sulfide. Okay? This 2 is the charge. You might want to be pausing this video and making this note. That 2 in parentheses is the charge of the ion. So what you really have here is iron with a +2 charge and sulfide or sulfur with a -2 charge. When you drop and swap those, you have FeS because the 2's need to simplify to 1 and 1. Anytime you have something that can be simplified, you need to simplify those numbers. Okay. I think that's all. I might be adding another video here for example problems, but that's really all that I wanted to kind of go through so that you're able to name and write the formulas. If you have any questions, jot them down on a piece of paper and bring them to class on Thursday, okay? Hope this helps.